Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of x sine square 3x dx. So let's begin. Now, we can see that we have the double angle formula for cos, which is cos square x minus sine square x. So we'll be simplifying the integral using this formula and a derivation from this formula. Now, because sine square x plus cos square x equals to 1, we can substitute cos square x as 1 minus sine square x. Thus, this becomes 1 minus 2 sine square x, which is equal to cos 2x. Now, with a little bit of shuffling of the terms, we can write 1 minus cos 2x upon 2 as sine square x. So, we can see that sine square of an angle is equal to 1 minus cos double of that angle upon 2. So, we can write sine square 3x as 1 minus cos double of 3x becomes 6x upon 2. So that's what we are going to be substituting in our integral right here. We can write this integral as x into 1 minus cos 6x upon 2 dx. This will make our work for integration much simpler. Now we can just expand this integral by opening the bracket. So we have the integral of x by 2 minus x cos 6x upon 2 dx. Now we have 1 by 2, we can take it outside because it's a constant, and we can integrate these two separately. Integration of x dx minus the integration of x cos 6x dx. Now we know that the integration of x would be x raised to 1 becomes x square by 2 because the integration of x raised to n is x raised to n plus 1 upon n plus 1. So we have 1 by 2. Into the bracket we have x squared by 2 minus the integration of x cos 6x dx. Now this we will be integrating using the bypass rule, for which we need the Lie rule to decide which term should be the first term and which term should be the second term in the bypass formula. The bypass formula, u into the integration of v dx minus integration of differentiation of u into the integration of v dx. Lie will help us decide which term of the integral we should keep as u and which term we should keep as v, depending on which term is easier to differentiate and easier to integrate. So we have a cos term, that is a trigonometric term, and we have x raised to 1, which is the algebraic term. Because algebraic comes before trigonometric in this integral, in the Lie rule, we will keep x as the first term, that is the u term, and we will keep cos of 6x as the v term, because cos is the trigonometric term, which comes after the algebraic term in the Lie rule. So now let's begin integrating. So we have x into the integration of cos 6x dx minus the integration of differentiation of x into the integration of cos 6x dx. Alright, so the integration of cos is sine, and we also have to keep the coefficient of x in the denominator. So we have x sine 6x upon the coefficient of x here is 6 minus we have 1 into sine 6x upon 6. Now we can keep 1 by 6 outside of this integral because it's a constant, and again we will integrate by parts. Remember, this is our whole integral, this is the entire answer. Now we just need to integrate sine 6x. Integration of sine x dx is minus cos x dx, because the differentiation of cos x is minus sine x. So the differentiation of minus cos x is sine x. Now integration of sine 6x would be minus cos 6x upon 6, which is the coefficient of x. So we have 1 by 2 into x square by 2 minus x sine 6x upon 6 minus 1 by 6 into minus cos 6x upon 6 again. And because now there is no integral term, we don't forget to add plus c. Now let's simplify. We have x squared by 4, because I'm just opening the bracket, minus x sine 6x upon 12, minus minus here becomes plus, 6 into 6 into 2 becomes 72, and we have cos 6x in the numerator, plus c. And it looks like I've made a mistake here. I was supposed to add a bracket, which is why I made a mistake with the sign. Here it's supposed to be minus, but here it's supposed to be plus, which is why in the final answer it should be a minus right over here. So guys, learn from my mistake and don't make a sign mistake. Pay attention to the negative signs. They can mess up the entire answer. But now this is the final answer, just like it's given in the textbook. X squared upon 4 minus x sine 6x upon 12 minus cos 6x upon 72 plus c. Oh, this was a lengthy question. But that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.